Thank you for joining today's session. Actually, this is a three-phase session on this new topic which is coming up in the last couple of years called digital twin. As you have seen this digital twin in various news and article, my colleagues in these three series webinar will try to demystify and show you the various components within the digital twin. In Esri, we call it a living digital twin because the cities is meant for people to live and the digital twin is actually a replica of the city. Now, when we talk about the replicating the actual as built city, there are many components into that. Obviously, the planning is important component because unless until you factor in the 3D component of the city, you cannot really do the modern level planning where there is an immense pressure on urban planner to take care of the rapid urbanization and human settlement growth coming up. But also, if you see the next session, which is on the February 11th, we'll be touching upon how the city is becoming a living city by infusion of a lot of data coming from various sensors, which multiple government department is placing within the city. Whether it is an environmental sensor, whether it is a pollution sensor, whether it is a water quality sensor, or whether it's a floods related sensor, or whether it is a simple CCTV, which is getting placed by virtue of various initiatives. These infusion of the sensor data makes city a real digital and living city. In the third segment of this webinar, we will be touching upon how the AI/ML can help the city planner. They primarily help into detecting and monitoring change. Now, it can be various component on that. And in the February 18th session, we will be talking about how this AI/ML is helping GIS workflows into the ULBs in respect to the detecting and monitoring change. So I would like you to attend all these three webinars so that you get a complete perspective of the digital twin. It's a so vast subject. It is not possible for us to bring everything content within a one webinar. So we thought of making these three series of the webinar. And in the last session, we will be sharing the QR code of the next two sessions, which you can use it for registering on that. My colleague, Dr. Ruma Chakravarti and Debabrata will be continuing and demonstrating this today's session. Over to you, Ruma.
Thank you, Digan, for a nice introduction to our webinars. Now we will talk about today's session. My screen is visible? Okay. Okay, so today we will take on the digital twins changing the planning outlook of Indian cities. So how we are going to look into what are the expected outcome from today's webinar. So why we should shift from 2D planning to planning on digital twin? Many of you might be surprised that why do we need to plan on the 3D digital twin? What aspects should be considered while we undertake planning on a digital twin? What is the process of planning in digital twin? And we will look into the use cases, the ArcGIS technology advantages in digital twin scenarios, and then we will move on to the demonstration. So demonstration will be taken by my colleague, Mr. Debabrata Sadhukan. So let's begin. So if you look into why modern days urban planning in India, how it is changing, the cities are growing at a very fast pace, horizontally as well as vertical. You can see that the vehicles are multiplying, the problems of the cities are multiplying, as well as the economic growths are happening. So all this is happening in such a fast mode that we need some dynamic way for planning. The complexities in the cityscapes are increasing. We cannot rely anymore on the static master plan for 20 years or neither on the old norms because every day the things are changing. And now our planning needs urban design, urban management components, and 5D planning. So 5D planning I will explain later, but let me first talk a bit about the urban design and urban management parts. So when we talk about the problems in the city, like water supply, if we take upon the water supply or the urban pollution, so many of the problems are because of the scarcity, and many of the problems are because how we are managing our resources. So while for managing of the resources, we need to look into the all the substratas of a city. So the substratas, the surfaces, the underneath, the hidden parameters, how they interact with each other, how soil and geology impact. And so we need to take care of the urban management aspect and then the urban design. Today, much depends upon the urban design, that how we design our buildings with a growing vertical heights, because we are shrinking our green spaces. So now in many countries, we are talking about vertical green spaces. We are talking about circular city patterns. So from building to building, we can join the network, the transport network spaces. So that type of aspects are coming up. So essentially, we have to look into the 3D mode for those type of city planning. So if I look into simply in this form, it looks like 2D. We used to have the feel in the form of latitude and longitude only, and we used to have the traditional way of looking into our network lines, into our utility lines. And now we are talking about the GIS-based planning development in 3D, and which are BIM based. Now, what is the basic difference? So when we are talking in a 2D arena, we are talking about where is it? Means it's where the school is, where the hospital is, where the utility line is. Now, when we are talking in digital twin terms, we talks about what does it look like? How does it behave? Because we are talking about behavior of the things in 3D space and what happens if we change it. Like when the city is growing, what are the problems? Where the shadow aspects of there, whether the ventilation is proper or not, whether the sunlight we are getting it is or not. And as we are talking about the growing cities, so our infrastructure constraints will be also have to follow that how much the city is growing. Suppose I am growing the vertical heights of the city and not taking care of the road width in compared to them, or the infrastructure pipelines width in compared to them, then it will be a problem. So these are the relationships which we are talking. These relationships need to be established over the digital twin. So if we talk about, in short, traditional planning relies on static maps and documents, while living digital twins evolve with the city. It integrates planning, implementation, and operation. Three aspects of it. It like all of the architects and planners are quite used to that. They used to create the 3D models over their board and then look into what types of planning need to be done. So when we are doing a digital twin, we are putting up the same type of cityscape. If your city is in front of you in a digital arena, you can well understand that where the problems are, how we need to plan, how I need to grow the city further. And over to that cityscape, we are adding the live data sets. So whenever the things are changing, it is getting automatically updated, whether it is in terms of traffic. So nowadays, we are not doing the OD surveys on the road. We are having the live traffic data sets that is coming from the different type of sensors, the GPS, the satellite image, combination of all. Then we have algorithms to convert that into real sense, that where the traffic is getting blocked every day and why it is getting blocked, we can look at in a 3D domain. Then come the sensors, the SCADA sensors of water, electricity. We can look into which are the problems of heavy load, or where the services are disrupted because of certain things. And then we have this flood sensors and all, so that we can also prepare ourselves with the climate changes. So all this and the simulation aspect of it. So we understand with the data that how we can plan for the future, how we can make it ready for the future. So again, coming back to the aspects of digital twin, this will be the aspect. So first will be the terrain, then comes the buildings, then comes the infrastructure, then comes the mobility aspect of the cities, then comes the digital layer or the IoT sensors, and finally a complete virtual layer of digital twin by combining each of them. And each layer can have its own issues, it's having its own management and planning requirement that we are going to cater through a digital twin. In this terms, in remote sensing and GIS terms, it can be, you can see the DSM models and DTM models. Sorry, you can have a look at the extraction of the buildings, then the complete infrastructure services, the mobility services in the city. And as we are talking about a living digital twin, so it will be integrated with the cameras that how the vehicles are moving. So not only the live traffic, but also how the vehicles are moving at a particular point of the time using the camera sensors. And then finally, it can have a lot of other IoT sensor layers, like the crime what is happening in the city, or the grievances that are coming up for different aspects in the city, that how everything can be interrelated in a 3D space. This is how a complete digital twin will talk to the planners. This is why and how the aspects of different components talk. So this is the real city scenario, that where what is there, what type of buildings are there, what type of infrastructure are there, where green space is there. Then we are testing and analyzing. So testing and analyzing, you can see that if we have add up some power supply sources, if we add up the buildings, then how the scenarios change. And then we look into how to implement that. So when the implementation comes, we have used our digital twin as a test bed, and then we can implement that. Today also we are doing that. The same thing in the master plans, but we cannot project that how it will look like. So digital twin is basically how it will look like. What can be the possible problems which cannot be analyzed in a 2D surface. Today, when we look into our master plans, there is a yellow color showing the residential area, red color showing the commercial areas, but we cannot assume the volume. And if we cannot assume the volume, that we cannot do the justice of providing infrastructure to the people. So 3D will provide that thing, that how the things will change. Now, if we talk about what are the inputs of digital twin creation. So all of us knows that when we have to talk about digital twin, it can be the LiDAR data, it can be the drone data, it can be both LiDAR and drone, and orthorectified satellite images. It depends on what type of provision, what type of budgets we are having for undertaking this type of surveys. Then we talk about asset models. So there can be a live tracking of assets using moving LiDARs. We can also use the GeoBeam things in ArcGIS and the GPR, all of them factoring to the digital twin creation. Then the third component, which is aspiring to our living digital twin, that is the sensor data. Now the sensors are of three types. One is the stationary sensors. So the flood sensor is a stationary sensor. It tells when the flood water rises to a particular height. Then we have moving sensors. So bus GPS can be a moving sensor. Then there are event capture. So there are cameras, and it can capture any type of accident, any type of clashes, or any type of accidents in the city. So that type of things can come up. There are other data sources. So one of the data sources is mobile data capture. So over the digital twin, if we have this mobile data capture, we can immediately update our asset details which are coming up. The ERP integration. Every city is having some ERP in some form. Uh, there are digits, there are Upyog, then there are SAPs. So all can be integrated with this platform for continuous updations of assets and digits. And then this grievance system. So grievance can be in the form of planning. It can be like my land has been taken and it has not been developed. So whether I will get the compensation or not from the planning aspect in development authorities, or it can be from the municipal aspects of different types, like for tree cutting, for animal, for disruption in water supply line or sewerage blockage, anything can be there. So online grievance inside the digital twin will pinpoint where the problems are coming up. Now coming to the ArcGIS technologiescapes in digital twin. Now, why I have kept this slide? Because digital twin is not one single thing. That okay, I have flown a drone and I have done all the justice by creating and extruding the building or the visualization that how the things are there. So there is a lot of mixtures that need to be taken up if we want to bring the digital twin in a real sense. So first product is ArcGIS Reality, which talks about which gives a complete visual thing, complete how it is in front of you. Then we have factors like in ArcGIS, we have 3D base maps. These base maps are accurate in terms of height. So all the buildings which you can see in that 3D base map, this have accurate heights and these are available with the enterprise version. Then we have India DEM, which is available in ArcGIS Living Atlas. This you can utilize it for laying off any type of infrastructure. We have ArcGIS Pro, many of you are aware of it, which is used for creation of the digital twin. We have ArcGIS GeoBIM. We have a GeoBIM extension for looking into the infrastructure project details or the building layers detail. We have ArcGIS Urban, which is used in many ways for planning. This is one of the tools which can focus on where the development has to come up. The zoning bylaws can be integrated, project details can be integrated in it, as well as the planning of the heights can be planned into it. ArcGIS Enterprise, which have several other tools to visualize in 3D. You can also have the 3D symbologies, 3D stack diagrams to look into the thing. 3D voxel creations can be there. 3D thematic maps can be there, as well as this can be built into the dashboards and regular workflow. Because without workflows, without decision support system, there is no use of this digital twin. Then we have ArcGIS Indoors, another product which you can use over the GeoBIMs also. It involves the workflow inside the building, that if suppose a fire catch up in any part, or a hospital need to, people are going to hospitals, they usually, you might have seen that people are moving here and there, they are not aware of which type of facilities are there. ArcGIS Indoors can be used to build up that type of facilities. Suppose you are going to a hospital, in smooth way they can tell you or guide you which facility is available where, which ward is available where the laboratories are. And then site scan for ArcGIS, another product in which the drone data and the LiDAR data can be converted into planning ready data sets. So that is about ArcGIS technologiescape. And if I talk in that terms, ArcGIS has a technological superiority in the sense that it can integrate IoT sensors, the SCADA sensors, the inspection data from mobile apps, which can work anytime, anywhere. The work history data set, asset data histories, that my colleague Devabroto will show you how the maintenance histories can be there. The infrastructure data in BIM, then the GIS data set, the normal GIS data analysis, everything, and dashboard-based visualization, all into one. So a lot of technological gamut can be seamlessly integrated for a smooth planning. This is, you may be finding it okay, so much of write-up, but it's a thing that how the aspects of digital twin can be taken up. Core representation, the volumetric view XYZ, real world height, depth, and forms. The spatial context mirrors the physical, it mirrors the physical world exactly in terms of building, terrain, infrastructure in true form. Primary ArcGIS components like Pro, ArcGIS Urban, Reality, Scene services are available in this. Building representations in the form of multi-patch, BIM-derived models with floors, setbacks, roofs, facades, which are important from planning aspect. Data sources can be BIM, LiDAR photogrammetry, reality mesh. We can integrate all of them. Analysis capabilities like shadow, line of sight, skyline impact, volumetric, FAR and FSI. Urban regulation, automated 3D rule checking, height, building, solar access, how much is there. So all these urban regulations can be looked at. I will take you through few of the use cases that how a mixture of all this has been taken care by different cities. Scenario planning, dynamic what if simulations, if new buildings, road widening come up, or you need to plan for a transport oriented development plan. Infrastructure planning, vertical plus underground utilities, flyover, tunnel, metro alignment, all in one. Surface, over the ground and below the ground, even the atmosphere. So one of the examples will show you how atmospheric parameters help you to analyze in digital twin that what type of decisions need to be taken. Environmental impacts, micro level impacts can be simulated in this. Then stakeholders understanding, intuitive, immersive, decision friendly. As I have mentioned that over the mobile or over the web app, person can geolocate that, okay, some grievance has come up and how that can be resolved with a complete workflow. Web-based 3D scene, storytelling, participatory planning. Operational readiness, it is directly usable for city operations and asset management. Again, another example which my colleague will show you. Real-time integration we will take up in our next webinar. The change detection, automated change detection using reality capture updates can also happen in digital twin. It acts as a living and evolving digital twin. It is evidence-driven and simulation-based. City-scale digital twin scenes and dashboards can be created, and the role of digital twin, it is core engine for digital twin. We may tell that it needs a lot of amount, higher data, higher skills, but then the ROI is very, very high in that aspect, because we are talking in the terms of 3D. We talks about our improving our business processes in 3D, which increases our ROI for the city. Now I will come up with a few of the use cases and how you can use your digital twin aspect for the planning. So when we are talking in today's planning terms, we are talking about infill development, redevelopment, mixed use development, and vertical growth. And all of these aspects need a 3D scenes. If you try to do it in 2D, the city which is already dense, how do you look into that? How I can utilize my best space with a complete planning and a quality of life that need to be given. So this is how it can be used in the terms of that. Let me show you by an example. This is one of the international example where a particular patch has been selected for urban densification. So first aspect is that where this urban densification can be done. So this was a railway land which has been chosen for that type of development. It was a government land, so they have decided that we have to put up a plan. Then selected land use for the content. So land use plan was there. Then the parcels. So these are the existing parcels which are there in that particular patch. Then vertices of the selected area, that this area will be selected for the redevelopment plan. And then it has been taken up that, okay, this was the city, these are the details. And then we have added up the different planning sorts. So this is the existing land use of that particular area. Then this is you can see that the railway patches are there and some buildings here and there are there. And then we have a plan for the future land use scenarios. So ArcGIS Urban allows you to do that. You can select the scenario name and based on the existing condition, what type of development you can look into. So it talks about land use, development, and capacities. You can allocate the space use. You can select what type of development I want to take up. So all the rules are specific in ArcGIS Urban. So if I am selecting residential multifamily development, so it asks me to select the color, it's what type of space uses. So if I'm looking for a affordable housing, accordingly the minimum dimensions for that affordable housing will come up in that we can fix up, and then we can run that model in any part of the country. So select land use type. This is allowed space use. We can use it for residential, office, cultural, retail, affordable housing, and then parking. So all these spaces have been defined, and then we again come to the same space and then creating our plan. So we have this zoning type. So we now marked up the particular zoning type. We codify that. It will be a mixed use type. What will be the maximum coverage? What will be the maximum FAR? What will be the maximum height that can be fixed up? Along with that, all the setback rules can be incorporated in it using the ArcGIS Urban. So you can see rear setback, side setback, front setback, and then you define your model and you push up in that area, that how it will look like. And this will be our targeted development aspect in that. And finally, we look after that. This will be high density residential. What type of things are permitted inside it? What types are restricted in it, that we can define. And finally, we can come up with this type of buildings, and we can look. Now, all these parameters. Now, what is the advantage of this digital twin? That you can change the parameter and change the scene. So you can look into that, what best type I can use, how I can utilize that limited space in a best way, how this mixed use component can be changed, where the high density has to be to come up, where the low density can come up. That type of building plan can be done in that. Along with that, not only that, we can also fix up the other capacities. Number of household, if we are planning an area with the job aspect, because especially in the greenfield areas, we need to plan this. How many jobs will be created in that particular area? Fixing up the rest of the things. How many daily trips will be undertaken from that area to the CBD or to the office spaces? Energy use, we can estimate with this 3D digital twin, what will be the energy use, what will be the CO2 emission, what will be the internal water use, external water use, wastewater, and solid waste management requirement. So this way, ArcGIS Urban can cater to any of your densification projects, that how you can look into the plan in a shorter period with more alternative with given parameters, and it will be a real sense parameter, full-fledged planning. Now coming to the reality, because everyone talks about, when we are talking about digital twin, everybody talks about how it should be looks in a real form. So this is the reality, and you can see over the top that it can be selected via drone, which are used by aerial, as well as with combination of drone and aerial and satellite. So all the three parameters has been utilized world over using the ArcGIS technology to create the digital twin. And there is a list. I will, at the end, it will come up here, that where you can find that. And world over has used the ArcGIS reality for looking into this type of cityscapes. This is for Boston, and we can do different type of immersive experiences in this, like what is the fog density, if it rains how it will look, if there is a sunshine how it will look, if there is a shadow how it will look, during the different parts of the day how it will look. Then the sight and line of sight, suppose we are placing any important thing, then what is the line of sight from that particular aspect, from that particular point? So this red line shows this disrupted line of sight, and green shows that, okay, line of sight is clear from this particular area. So this can be fixed up for the security of the city. then you can also do the slicing. Now, how this slicing helps? What is there? Scenario that before bringing up this type of development, how the city used to look like. So what are the cadastral details in that? Then how we have planned the city in that form. So this type of slicing are available in ArcGIS Reality tool. And this is the final lookup, that how it looks up. It integrates with the different type of sensors in the city to make it a living digital twin. So you can see this in ArcGIS Reality Mesh Gallery. You can see the world over how they have used ArcGIS Reality for creating digital twins. Now, I have mentioned you that there are a lot of technological aspects which can be combined for a planning. Saudi Arabia has used multiple technological things for their digital twin implementation. So that integrates the IoT sensors, tracking systems, air traffic data, CCTV, BIM models, ERP data, HR data, attendance system, SQL and Oracle database. So all of them, including, if you see in right hand side, there are different simulation engines also. Unreal Engine, Autodesk BIM models, Autodesk Maya, everything has been integrated into one system of ArcGIS Enterprise for doing a living digital twin model. So this is what they have done for ArcGIS Urban, which I have shown you earlier. If there is a vacant plot, how the cityscape will come up. Then they have integrated that with the live traffic data and then done the complete analysis, that which parts of roads have what type of carriage width and where the traffic problems are there. Okay, so for that they have used the HAIR technology for getting the real-time transport data. This is the combination of BIM and indoors. What I was mentioning you, when you are coming to any hospital, when you are coming to any facilities, it can be a school, it can be a hospital facility, it can be a government building. In government building, where you will go, where which person sits where the secretary sits, where the town planner sits, everything can be seen like this. And what are the problems? If there is any toilet which is leaking, which floor it is? Door sensors, how it is working. So the complete security of any particular building can be managed with the IoT sensors and integrating that with the ArcGIS indoors. You can, at the bottom, you can see even the cameras, how its visibility is, up till which part it can look into for the security reason and where the privacy can be maintained. That type of things can also be developed. These are the BIM models. The BIM models can be developed, can be utilized. These are the Revit models which are developed in the Autodesk 360-degree models, which is integrated in the GeoBIM for the continuous project monitoring, how the buildings are growing and how the projects are happening. If there are any other projects outside it, that can also be tracked using the BIM models. Finally, we can do other types of analysis also. Which floor, what type of facilities are there, how many are, suppose there is a hotel, how many are occupied room, or if there is a building, now we have a large number of buildings which are available for availability for residential or for commercial purposes, how many of those floors are occupied and which are free. That type of analysis can be taken up. And finally, the reality capture merges with drone to map for a complete cityscape. So which floor, what type of facility is there, how these things have grown up, that type of scenarios has been developed in Saudi Arabia. So this is the example of Saudi Arabia, which is a mixture of several parameters. Lastly, this, what I'm talking about is a 5D planning. So 3D space plus time. So you can see that if I'm comparing over the period of time, you can see the left bottom, that over the period of time, how the construction has happened and what is the cumulative cost of this particular project. or you can look into this form that how different technology can be integrated for a 5D planning. So it shows the moving factors, the BIM factors, the analysis on the enterprise of 3D themes, the 5D planning for future like this, the ArcGIS Urban, whatever I have shown you, for the heritage aspect, how to preserve the heritage, how to look into the complete BIM models, how to simulate the flood, how to map the network area. So these are the SCADA integrations of electricity, and then planning the scenarios and IoT integration. Now we will move to the different demonstrations. I am putting over to my colleague, Mr. Debabrata, for the same. Thank you very much for patience here.
Thank you, Roma ma'am. Hi everyone. My name is Dhruv.
Hi everyone, my name is Debabrata. Share the screen.
Let me share my screen. In the world of urban administration, there is a silent challenges that cost municipalities crores in lost revenue. Now, in every single year, currently most urban local bodies depend on 2D raster data sets or go to do manual surveys. But let's be honest, 2D imagery has a high blindness problem. From a top-down 2D view, a two-story building and a five-story building can look identical. This vertical graph creates a massive mismatch between the property register and the physical reality on the ground. Whether it is an undeclared floor or an expanded building area, these inaccuracies aren't just administrative errors. These are missed opportunities for urban development and clear violations of building bylaws. Today, I'm going to show you how we solve this by moving from 2D maps to 3D digital twins. Now, I like to present my solution to everyone. Thank you.
Now we have created a solution. To solve this, I have developed a workflow that identifies these mismatches with surgical precisions. We are moving beyond a flat analysis into a 3D digital twin environment. What is a digital twin in this context? It is more than just a 3D model.
Debabrata, your
It
audio
is
is
a
not
bridge
coming.
between the as-built reality, what actually exists on the street, and as recorded data sitting in the government's tax returns. By creating a digital replica of every structure, we can ask the map questions that a 2D layers simply can't answer. For example, does the height of the building match its tax bracket? Let's look at exactly how we build this. Now, I like to mention the foundation of any digital twin is a high fidelity data. Our process begins with high resolution drone imagery, processing the raw drone captures into high accurate 3D mesh using our products like ArcGIS Reality or Drone to Map. This gives us a visual context, the textures, the windows, and the actual roof lines. Now, in the phase 2, we have to understand the vertical extraction. This is where the GIS magic happens. We use DSM, Digital Surface Model, and the Digital Terrain Model layers. Now we have to understand what is a Digital Surface Model and a Digital Terrain Model. Imagine you are looking at a city. The DCSM is like a blanket draped over everything. It shows the tops of the roofs and the trees. The DTM is just a ground or the floor of the city. By subtracting the ground DTM from the top of the buildings, we left with only the height of the structure themselves. Thus gives us the absolute height with mathematical certainty. Now coming up with the phase 3 of our processing, right? Now what we have done, we have took these high data and joined it specially with the integrated household survey data from the property register. We know the average height of the floor in this region is 4 to 5 meters. If our digital twin shows a building is 12-meter high, but the register say it's a G plus 1, that is a 2 floor, the system instantly flags a floor mismatch. This allows us to identify not just where the tax is missing, but how much. Now, how do we present this? We simplify the complexity into a thematic LOD, that is the level of detail datasets. What is LOD? Now, coming to a LOD means that it's just a simplified 3D blocks. As you can see on the screen, we have color coded the city based on the compliances. Green represents the building that match the register, and orange which has a mismatch in floor. By clicking on any of these red buildings, a pop-up appears. It shows the property ID, the registered float counts versus the detected count, and crucially the estimated tax deficit. We are no longer looking at a static map. We are looking at a living record of the city's assets. This is defensible data that an officer can take into the field with total confidence. Now, how do we build this into an actionable thing? Finally, a digital twin is only useful if it's accessible. I use the ArcGIS Experience Builder to create a low-code, no-code dashboard, especially for non-GIS experts. An administrator doesn't need to be a drone pilot or a 3D analyst to use this. They can just simply use this application to filter the floor mismatches, to prioritize, search the specific property ID, and can able to generate records for field verification at a click of a button.
Thank you. This is digital twin approach doesn't just find errors. It provides a transparent, spatial way to increase municipal revenues and ensure fair urban governance. We are making the invisible visible. Thank you for your time. I'm happy to take the next use case to you. Now, the next use case is the precise plinth area and land use validation. Now, what is the problem? The problem statement is now moving to my our second major hurdle is the property tax collection, is the plinth area increases. Let me say share my second use case to you. While floor counts are a vertical issue, the plinth, the actual footprint, and the built-up area of the structure is often underreported in the property register to lower tax brackets. In 2D, a building footprint can be obscured by shadows, trees, or poor resolutions. Furthermore, the type of use, whether a building is residential or commercial, is frequently misclassified. A building registered as a small residence might be actually be functioning as a large commercial warehouse, leading to a massive revenue gaps. Now, I will present this solution to you regarding the use case.
To solve this, we have stepped up our detail. For plinth area validation, we moved from simple LOD1 blocks to LOD2 models. By utilizing the 3D mesh and DSM layers, we didn't just extract boxes, we extracted the actual geometry and boundaries of the built-up area. The LOD2 approach allows us to see the character of the building that often go missing in the 2D surveys. The process here is highly integrated. We use high resolution orthoimagery derived from our drone flights to trace the exact physical footprint. The physical plinth was then compared against the integrated household survey data. Because our 3D mesh is so high resolution, we can visually distinguish between residential structures and commercial ones based on rooftop assets. Now look at this application. We have applied a thematic layer. We are now showcasing building where the reported area in the register is significantly less than the detected area in our digital twin. We have also highlighted properties in different colors as per their usage type. It can be residential, commercial, or institutional. For example, a property paying lower residential rate but physically appearing larger or as a commercial entity. This visualization makes it possible for these discrepancies to hide. We can see exactly where the register says 1000 square feet, but our LODT model proves it is 1500 square feet. Now, this mismatch, as you see from this application, this mismatch can be well noted in the red color thematic layer. All these things has been built up in ArcGIS Experience Builder like the previous one. We've added a specific plinth mismatch filter where an officer can search for any property by simply searching it on the search bar or filtering it up. This provides a fair and transparent system. It is not about penalizing citizens. It's all about ensuring that everyone pays their fair share based on the actual space they occupy. With ArcGIS, we have turned the complex auditing into a simple visual and a low-code solution. Thank you.
Thank you, everyone. I would like to come to my third use case, that is the subsurface digital twins of water and sewage management. Now, the problem test statement is the high, the high cost of digging blind. While we have discussing buildings on the surface, a massive portion of a city's critical infrastructures lies hidden underground. For any water and sewage board, asset management is a constant struggle against the unknown. Traditionally, these underground assets are mapped as 2D lines, while which shows their horizontal location but fail to capture the depth and vertical separation. For example, two pipelines may appear to overlap on a map, even though one runs above the other in reality. The primary problem is that when a leak or a blockage occurs, maintenance teams often don't know exactly where to dig or what depth. This leads to a trial and error excavation, which is expensive, disrupts traffic, and risks damaging other utility lines. Without a clear 3D view of the subsurface, we are essentially digging blind. Now I will present the solution, a very interesting solution of the asset management of the water pipeline.
To solve this, we have created a subsurface digital twin. What we have done, we have converted legacy as-built CAD drawings into 3D GIS features. For newer projects, this can be enhanced using ground penetrating radars to capture the precise X, Y, and Z coordinates of existing pipes. Now, with the help of ArcGIS scene layers, we can visualize these networks in the underground projections. This allows an engineer to see through the pavement and understand the spatial relationship between the water mains, sewer, and sewer lines. Thirdly, I like to mention a key part of the managing this asset is understanding their life cycles. Not all pipes are equally created. In our digital twin, we have categorized the network by material type. Now we have three type of pipe materials, that is the CI, TI, and MS. One is the cast iron, ductile iron, and mild steel. Therefore, these pipes have a typical life cycle from 50 to 100 years. The ductile iron has a life cycle of more than 80 years, as well as the mild steel have a life cycle between 50 to 70 years. By knowing the material and the year of installation, the digital twin can automatically understand and give a decision when this pipe required maintenance in its life cycle, and what is the last survey been done in these pipes, and what is the due date. Now, look at this executive dashboard. To make this data actionable for the board, we have implemented a series of intelligent filters and alerts. The system segments as due for maintenance based on the last survey days and life cycle thresholds. You can see this categorized as due, immediate, and near term. Now, by selecting a segment, this administration can seize the full history, pipe diameter, division, installation date, and the results of the last survey. By doing a special filtering, we can do on the pipe material and maintenance debts. Finally, we have closed the loop between analysis and actions. Once a critical segment is identified, the administrator can use the maintenance approval form within the dashboard. By simply mentioning the pipeline ID, they can able to trigger a necessary action on it. Thank you.
Now, I'll be coming up with my fourth and the final use case.
To
For our final use case, we are looking at the challenges that impact every single citizen. That is the air quality or the air pollution problem. Traditionally, air quality is reported as a single number or a 2D map, but pollution doesn't exist in 2D. It is a three-dimensional volume that moves, settles, and disperses based on atmospheric conditions. The real concern for urban planners and health officials is understanding exactly how pollutants concentrate at different heights, where people live, work, and breathe. To address this, we have moved beyond simple heat maps to create a 3D atmospheric digital twin. Now I'll present that digital twin to you. Now, before that, I will be telling something on the specifically why we are focused on the PM 2.5 data, because unlike larger particles, PM 2.5 is fine enough to enter the bloodstreams and cause long-term health issues. Because it is so light, its concentration is heavily influenced by height and atmospheric pressure. Using real-time AQI data from various monitoring stations, we captured not just the surface value, but calculated values across different atmospheric Z values, that is 0, 150, 360, and 600 meters. Now let me present the solution to you.
visualize this in ArcGIS Pro, we didn't just plot points. We have done a height-wise calculation. We took the raw mass concentration values and calculated the predicted dispersion at multiple height intervals, like at ground level, 150 meters, 300 meters, and 600 meters. We have also categorized the AQI based on the height, and we have given them as poor, moderate, satisfactory, and good. Now, we have utilized the empirical basing rigging to create a 3D prediction model. Now, what is the result of it? The result is a voxel isocline surface. Think of this as a 3D weather map that shows clouds of pollution. This model allows us to see the volume and density of PM 2.5 as it moves through the urban canopy. Now, the results are immediate and striking. The red colors in our model represents high density concentration of PM 2.5. By viewing this in 3D, we can see the areas where high rises might be trapping pollutants at street level. How high the very poor air quality extends into the atmosphere. Exactly which residential or commercial areas are being subjected to the highest concentration of the toxic air. We are no longer guessing which areas are getting affected. We can spatially prove the vertical extent of the pollution. Thus, atmospheric twins allows city administrators to issue targeted health advisories and design better urban ventilation corridors.
Thank you, everyone. Now I will be handing over to Vishal Rawat sir for FNAQ.
Thank you, Devrata. Thank you, Rupa.